Good morning, ladies and gentlemen. We want to welcome you today to today's webinar. We have the topic laser welding redefined, compact, integrated, and efficient. And what is behind that and what kind of machine concept we want to present you today, we will see in the following. First of all, if you have any questions, please do not hesitate to type your questions into the chat function. We will try to read them all and to explain them as good as possible during the webinar or maybe at the end of the webinar where we have some time left for questions and answers, of course. Then let's take a look at the overview of the webinar. For you, we have presented today roughly 35 to 40 minutes of presentation with interesting content. We try to keep it as quick and interesting as possible. And afterwards, we have 15 to 20 minutes for the questions and discussion. The webinar will start with a brief introduction of ourselves, of the speakers, of myself and my colleague Konrad Eibel. We will take you today through the webinar and introduce ourselves, introduce the EMAG LaserTec as a technology company of the EMAG group. And then we jump directly into the topic laser welding of powertrain components. This is what it is about today. We take a look at the process chain. We take a look at current state-of-the-art solutions as a basis for the following. And the following is then the highlight. The big highlight today, the freshly released new EMAG Laser Cell 6i, and what that I stands for, will we learn in the following. We take a look at the concept itself. We take a look at the process steps, the functionality, and where we can save some money. This topic, the ELC 6i, will be presented by my colleague, Konrad Eibel, who will serve today as a technology expert and product expert for us. Okay, then we will sum up the benefits of the ELC 6i. And last but not least, I have another point I would like to invite you to. The title is EMAG as a Technology Partner. We want to show you how we understand ourselves as a technology partner and how we can serve you from the process development to the production system. And last but not least, we have the question and answer round. Okay, then let's start with a brief introduction of ourselves. My name is Daniel Rujanowski. I am responsible for 2 departments at the EMAG LaserTec, for the technical sales department, where we are closely in touch with our customers, with you out there. We discuss your requirements. We take them to our technical departments. We elaborate together the solutions and create the quotations for our customers all over the world. In the Laser Application Center, where I'm also responsible for, there is where the magic of the laser happens. We make feasibility tests. We develop laser processes here together with our customers, with you, and we support, of course, on site if necessary, directly out of the lab. Okay, enough about my person and the departments. Now let me hand over to Konrad Eibel, our product expert today.
Thanks, Daniel. My name is Konrad Eibel. I've been working with EMAG for 21 years now, and I'm the head of offer engineering at EMAG LaserTec, meaning responsible for quotes for our customers, and will lead you, as Daniel has mentioned, today through the EMAG ELC 6i.
All right, thanks, Konrad. Let's now start with a brief welcome to Heubach. The EMAG LaserTec is a technology company of the EMAG Group, as mentioned. We are located in the beautiful Heubach village here, which is at the edge of the Swabian Alps, approximately 1 hour east of Stuttgart. You're more than welcome to visit us here in Heubach. In Heubach, we do the laser process development. We design and develop our machine tools, the technology cells, and we also implement and integrate the cells in our automation solutions here in Heubach. We set up everything here locally and do the startup and the commissioning and the acceptance procedures here on site. The technologies we have in-house are here depicted. Meanwhile, we have various technologies. starting all with the laser welding, which is our core competence for many, many years. And if you take a look at the parts, you see here the components, most of them are rotary symmetric, and a big focus is the powertrain of vehicles, of course. So this is where we have been specializing in for many, many years, starting with the laser welding with pre and post processes like thermal preheating or after treatment. We do the laser welding, and the second here you see is the laser cleaning, which is, I would say, meanwhile, mandatory for every laser welding process in order to clean the surfaces of the joining partners to ensure the highest quality of the laser weld seams. The next technology is the laser hardening. The laser hardening is being used in order to generate specific, very accurate hardness properties on the surface of parts like the tool holder you see here. Then the next technology is the newest one in the portfolio. It's the laser coating. The laser coating technology which is behind is called extreme high velocity laser metal deposition. Very long name for the technology, and it's of course one of the most demanding ones, I would say. What we do here is we melt powder, and we apply that molten powder, we weld it onto a brake disc, for example, as you can see here. Thereby, we generate a very wear-resistant surface of the brake disc in order to reduce the fine dust. And this is important in order to meet the latest European standards, basically the Euro 7 norm. And then let's come to the last two topics, which are not related to lasers. The thermal joining is a very established technology. We build machines for shrinking ring-shaped parts very precisely onto a shaft, for example. You see here a camshaft depicted. Then we have the clamping. We do the clamping by ourselves, meaning we design and produce them here in-house, which is very important for precise and accurate positioning. Now let's take a look at our technological scope. We do, of course, the laser technology, the laser processes themselves. We do the feasibility test, the process development. We implement them in our own machine cells. We take the machine cells and combine them with individual automation concepts. We marry everything with clamping devices, with software tools, which we make by ourselves. And what we get is a full turnkey solution. This can start from a standard single technology cell, a machine, which is maybe manually loaded, depending on your requirements. This can be up to a full turnkey solution. You see here a very chained system concept. I'm just reading a question, a brief interruption, ladies and gentlemen. The question is, hello, question about your location. Are you based in the same plant as EC and EMAG? Yes, we are indeed. We are 250 people here, and roughly 60 of them are in the ECM part, which is the electrochemical machining part of the EMAG group. So we have two companies here, and one of them, a smaller one, is the ECM, and the bigger one is the LaserTec. Okay, then let's go ahead. At this point, I just want to refer to the last point of the agenda. I want to take the chance here to remind you we have a topic on the agenda called Technology Partnership, which targets to the fact that such solutions you see here, they don't just come up or get straight out of our heads for you. This is always a strong cooperation, a partnership with our customers, with you, in order to find innovative and cost-efficient, highly productive solutions. But more about that later. Now let's take a look at the process chain. We picked here one part out of the drivetrain of a vehicle. This is the differential. It could be also any other part, like any gear wheel. It could be intermediate shaft or rotor shaft out of an electrical vehicle. Here the differential, because it's just, from my perspective, one of the most important parts in a drivetrain. So the process chain can vary. It can be different. There are certainly also upstream processes like mechanical machining, like grinding, turning, grinding, and gearing, but we do not want to regard them now. This is, of course, something we do in the EMAG group, in our other business units, and we work closely together with them. And sometimes also we create large chain solutions together. But for now, let's focus on the laser welding process chain. And this starts typically with a laser cleaning. As mentioned in the beginning, laser cleaning is important to have clean surfaces without any dirt, oil, any contamination for perfect laser welding results. After that, we have an optional preheating process for the pressing. Sometimes it's necessary, depending on the design, to have a thermal pretreatment. Then we stack the parts together, the two components, on top of each other, and do the pressing process, meaning we join the parts together to get one perfect part prepared for the laser welding. Then we have an optional preheating, depending on the material of the part. We have an optional runout measurement in order to make sure that both components are well aligned. Then we do the laser welding, and at the end, mostly we have a laser marking process for product identification purposes. And there are certainly also post-processes, but we want to focus on this chain for the moment, but we will see another example where we have also an ultrasonic testing attached later. Now let's take a look on state-of-the-art solutions. I guess many of you know solutions like this, know maybe our solutions. We have hundreds of those in the market, in the field. And you see here two examples on the left-hand side and right-hand side. Both have a similar process sequence. We have 4 process steps based on laser cleaning, on pressing, laser welding. On the left-hand side, we have the preheating, while we have a runout measurement on the right-hand side. But no matter if one process step is different, what is important is you see both versions look different. They look totally different. You can realize such system in different ways. You can use a rotary table. You can use a linear material flow. You can use for handling gantries. You can use robot technology. This is always based on certain circumstances at the customer side, on requirements and specific requirements, on how many different parts I have, and so on. So you need a lot of handling, which can look differently. It not only looks differently, the complexity increases. The control structure is different. The complexity increases in operating, in maintenance, in spare parts management, for example, and also in operating and keeping them in a process reliable manner over years. So these are points we've been discussing all the time with customers up to now. We discuss them forth and back, and the complexity does not decrease. It increases sometimes because the requirements are getting harder. The next slide shows you the required floor space. So it's not only the complexity of the handling systems, it's also the size. While maybe in the Northern American countries, space is not a big issue, but it's differently, for example, here in Europe, in Germany, the other countries, where floor space is not only expensive, in some cases it's just not available. And you see here that both versions take pretty much the same footprint. So all these topics are on the page, and we discussed them. We discussed them or have been discussing them during the last, I would say, months and years. Let me just summarize again the major points. It's like the numerous variants, the handling, the processing configurations. I mentioned the complexity of the system in terms of program sequences and software cycles. And sometimes when the customer wants to change the product, it requires often major conversions or modifications which cost money. And at the end of the day, there is high cost pressure. You all know that perfectly. Cost pressure in terms of cost per piece, or even area productivity, meaning how many parts can I get out of a certain space. So all these challenges made us thinking about how can we improve that, what can we answer to today's challenges in the world to increase the competitiveness of our customers. And this is what we want to answer now. Konrad Eibel, now our technology and product expert, will explain us how the brand new released machine concept will look like. But before we do so, I see we have a question. It says, hello, the laser cleaning can be replaced by a washing machine or differential components. Yes, washing machines are being used quite often, indeed. It always depends on the requirements and on the budget, of course. There are certain circumstances, but it is always possible. Konrad, do you have any addition to that?
Yes, what we see, especially in powertrain laser welding, most of the projects have laser cleaning as a requirement now. So I'm not 100% sure how the question is when laser cleaning can be replaced. Washing machines on differential.
Using a washing machine instead of laser cleaning. This is how I understand it.
Mm-hmm.
Yeah, I think laser cleaning is meanwhile very established technology.
Absolutely. So for a lot, or for even most of the project, it's mandatory. So that question doesn't come up. In general, yes, it could be possible, but for sure the washing process has to be maintained very closely, yeah, so that you don't get the effect of recontaminating the parts.
Exactly, yeah. All right, I hope we could answer your questions. If there's anything else, just let us know in the chat. We will take a look at it. We will keep an eye on it. Otherwise, I would say we just keep on in order to stay in time. All right, thank you then. I would like to hand over the floor to you. The show is yours.
Thank you. So we've seen the challenges and as EMAG LaserTec, having now decades of experience and hundreds of projects for laser welding systems, we know those challenges very well. So we decided to take a step forward, got together, got the R&D team working, and during the last year have come up with a new concept. And we are now very happy to introduce the all-new EMAG ELC6i. ELC6i is short for ELC6 Integrated. It's a concept that brings all the process steps that we have seen together in one combined system, meaning all the process steps are integrated here. For sure, the unified design of the cell, which we will see, will allow for a constant and not changing part flow, and at the same time, footprint can be reduced. The focus, for sure, is on powertrain components, such as differentials, intermediate shafts, rotor shafts, other gear or clutch parts. In general, welding diameters of up to 300 millimeters, workpiece heights of up to 300 millimeters, and a workpiece weight of up to 30 kilogram are possible. That means in general, for sure, upon request or when some slightly other dimensions come up, we will for sure check them, and experience shows in a lot of cases solutions can be found. Okay. The ELC6i, as the name indicates, the welding side of it is based on our proven and successful ELC6 machine. So first we are looking at the footprint. The examples on the right had footprints of 32 and 33.6 square meters. That was for 4 processes. The EMAG ELC6i starts at 3 processes. Those 4 processes can, however, be easily put in that machine, 21.4 square meters, meaning 33 or even 36% are saved. Now again, this is for 4 process steps. However, up to 6 process steps can be integrated in the EMAG ELC6i. Then, of course, the savings increase even more. For example, floor space will easily be 40% reduced. How is this done? How does the system achieve this? So let's take a look under the hood, or in this case, through the hood. There are 3 main characteristics of the ELC6i. First of all, as mentioned, the laser welding side of it is based on proven and successful concepts that we've used many, many times, meaning the ELC6, for example. Then we have the unified design of all the handling going through the process stations. This is done by around tagged system. Third characteristic is the combined housing, which is shown here in detail. The combined housing, of course, is going over all of the systems, all of the process steps. It has two functions. First of all, provide the laser safety. Second, take the function of the safety fence. Now, laser safety, what laser process steps can be integrated in the ELC6i? For sure, laser cleaning and laser welding. Laser marking, as we have seen, is in many projects optional or not required. But up to those three laser process steps can be integrated. In an individually designed system, that would mean 3 different housings in a lot of cases, all of them equipped with loading doors for bringing the parts in and out. And the same goes, of course, for the safety fence. Every system looks just a bit different. That means every time the safety fence has to be adjusted and individually designed. So that is also another advantage.
Oh, ladies and gentlemen, there's another question coming in. The question is, why is the machine only worthwhile starting from 3 processes? Okay, meaning why does it make sense to have 3 processes and more, right?
Exactly. Yep. Yeah, I can answer that. So by using the ELC6i, we replace a lot of handling systems. It is ideally used for 3 to 6 processes. And I guess the simple answer would be the break-even is just under 3 process steps. Yep. But for sure can go up to 6 process steps. If you have only 2 process steps, for probably a more simple design and an individual design would be used.
Okay, so this means that from 3 processes and more, the benefits, the advantages of less handling, of less floor space, and so on, they come true when we have more process steps. So the more steps we have, the more cost efficient it is.
Exactly.
Understood. Okay.
Yeah. So the process flow within the ELC6i is as follows. We follow the black arrows through the system. Load, unload onto fixtures is done in the top area. There the single components are loaded. They then go to the left side to the laser cleaning. After that, optional preheating for the pressing process is possible. We have then a press station. We can add another preheating station. On the right side, for sure, laser welding, followed by the optional DMC marking, meaning laser marking, before the parts go back to unloading. Now we will look at the process stations a bit more in detail, or the function units. First of all, the rotary transfer system. To understand the complete cycle, it's important to look at the part flow. So we see on the left side, again, the differential example. We have component A, meaning the ring gear. We have component B, meaning the differential housing. And what we are doing for sure is the assembly A, B. So the rotary transfer system rotates counterclockwise. And in the top area, loading takes part alternately between components A and B. So for this reason, the rotary transfer system clocks 2 places at a time. So 2 parts are then in the laser cleaning system on different fixtures. That means the cleaning optic shuttles between components A and B after half a cycle. Another feature to understand is then before pressing, when you put the parts together, when you press the parts together, there's a handling system necessary to place the ring gear, in this case, on top of the diff housing precisely, and then the pressing can happen. To the laser cleaning station. So As mentioned, the parts, the diff housing and the ring gear arrive on those fixtures. In the laser cleaning stations, there are two working areas, one left and one right. The fixtures are lifted up and the parts rotated. This is done by rotation modules that are placed on the bottom. They lift them up and do the NC rotation. This helps for different geometries, for different products even. So changeover can be reduced in this case. And then, as mentioned, cleaning optic shuttles between the working areas and therefore is positioned on an XZB axis systems, all with NC controlled axes. To the stations, to the process stations, preheating and pressing. So preheating processes, if required, can be integrated before pressing or after pressing, or both. On the left side, on the column, we see the positioning unit for the induction coil. This will lower the induction coil on the incoming part. The part arrives again on the fixture, and the same type of rotation module as used in the laser cleaning station lifts up the part and rotates it. This is to get a homogeneous temperature spread during the heating process. So then comes the pressing station, and there we have the handling system to precisely position the parts on top of each other directly before the pressing process. This will for sure be equipped as necessary. So sometimes one of the components, or let's say the trailing component, will need a flip over. Then a small flip over module will be integrated in this handling system. The horizontal movement is done easily. That's a pneumatic movement for sure, because the distance between the fixtures is the same always. And in the vertical positioning, the handling system has an NC controlled axis, again here giving the system more flexibility, making changeovers or later integration of different products easier. And of course, from the top, at the top of the station, we see the servo-mechanical press unit, which is commonly used. Such types of units are commonly used. Now to the heart of the ELC6i. Again, based on our successful ELC6 machine, the high tolerance requirements that are needed are met by configurations that are used in hundreds of systems around the world. The parts arrive, or the pressed part arrives on the fixture and is then clamped and located from the bottom by the spindle unit, which positions it vertically into the weld tooling. Spindle unit has therefore a C and a W axis. C axis is for the part rotation during welding. The W axis is for vertical movement and also for applying an axial force. The axial force goes then into the top weld tooling. This is located on a U-axis slide unit. Why is this a slide unit? Because the slide unit can feature different weld toolings. Again, reduce mechanical efforts on changeovers, increase the flexibility, and make later product integration easier. For sure, if there would be a single part flow, only one product on the machine, and that's all, this U-axis could be replaced by just a fixed bridge, which features only one weld tooling. Then the laser power comes, of course, through the welding optics, and the positioning system features X, Z, and B axis, all numerically controlled, giving the system, first of all, the precision necessary, and again, a lot of flexibility for changeovers, for future products, and so on.
This is a good point to take off a question. We have a question in the chat, ladies and gentlemen, and the question is regarding changeover. How long is the changeover effort? Meaning probably how long does it take to change from one product to another one?
Good question. So starting at zero changeover. So right now we are working on a project where we have 3 different work pieces, at least 2 different weld diameters, and we could find common solutions for all stations with no changeover. However, it depends, of course, on the project, on the products. If the products are completely different, if one part would be a shaft and one part would be a flat gear, then for sure changeover would be necessary. For that case, in a normal case would be around 20 minutes estimated.
So strongly depending on the parts, it might be necessary. If the parts are very similar, it's not necessary at all, right?
Yeah.
And if the parts change too much, if they're different in geometry, then we have some part-specific changes to do. Okay.
Exactly. Good. So for sure, with the experience we have in laser welding, additional process or process add-ons like filler wire, as shown with a roll on the bottom, are easily integrated as in our other solutions. And of course, state-of-the-art or even very new innovative welding technology or quality monitoring systems can be integrated in this machine concept without a problem.
Okay.
So far we have looked at the right side of this layout, at the ELC6i, up to 6 process steps up until laser marking. However, we see now here a complete layout for a production system, including some post-process steps. That is, in this case, and we see that in a lot of differential welding projects, brushing, meaning here a brush station, and also then ultrasonic testing. So how does the ELC6 fit into the complete system? So again, on the right side is the ELC6i, and on the left side are, let's say, the post-process steps. So the solution here shows a central conveyor system with pallets. On the left side, the operator loads the single parts. They then travel counterclockwise to the top, are taken by a gantry loader 1 to the handover position of the ELC6i. Then, as we've now seen, come the process steps: laser cleaning, pressing, laser welding, and marking. Before it goes back to handover, again, the gantry loader 1 takes them then over to the left side, to the post-process side. And another gantry loader then takes over the functions of brushing and ultrasonic testing. When all this has been done, the finished part then goes back to the top of the conveyor, and which transports it back to the operator for unloading. So as we can see here, very, very compact, obviously on the right side using the ELC6i, but also the solution for the other handling, for the other process steps, was done in a very positive way. And this linear design is for sure very compact and offers a lot of advantages in that way. Now to probably one of the most important topics of today, the cost effectiveness. We have looked at this as cost per piece. So this is what matters in the end. How much money do I need to produce a part per year? So on the right side, we see the factors which we have, which we can influence and which we will positively influence with the ELC6i. First of all, depreciation, yearly depreciation, floor space costs, and also maintenance cost. So for this purpose, another concept was taken as the reference and therefore put to 100%. What is the biggest factor? Obviously, the depreciation being influenced by the invest, which is reduced by 15%. Second, the floor space cost. This has the, let's say, the highest percentage of reduction of over 30% here. However, it's not as big of a factor. And then for sure also in maintenance, remember we have unified designs. We always use the same rotation models. We will always have the same cycles in this system, in the ELC6i. So that means maintenance costs also go down by a good 10%. Overall, that means in summary, these factors will have a 15% reduction as compared to another individually designed system. So, summing it all up, we are very convinced of this solution. We are happy we could introduce it today. To sum up the benefits, we have, of course, the footprint reduction. We have compared in detail also the lead time. This is also one thing that can be improved. Usually we talk about 13 months. In the case of the ELC6i, it can be reduced by over a month, so meaning under 12 months. Biggest factor, probably the 10 to 15% investment reduction. Then the software complexity, obviously, we know this helps in every step of the project. Then the mentioned better maintenance and also using standardized components, a better availability of spare parts. Summing this up, we are very happy and convinced by the solution. Yeah, and are looking forward to the projects quoting this.
Thank you, Konrad, again, for that great presentation of the ELC6i. I think there are a lot of benefits, significant advantages we can take advantage of, you can take advantage of, which increases your competitiveness in a global challenging world, in a global competition currently. I think this is more important than ever. Before we go on, I just see a question here in the chat, which says, what cycle time can be achieved with the system? Konrad, can you tell us this?
Short answer is under 20 seconds, depending again on the project, on the product. Right now we have a project where there was a differential, and this was even with seam finding and quite a big weld diameter possible in just over 19 seconds. That is not the complete end of it, but for sure we can say under 20 seconds is not an issue at all.
Okay, but I would guess it's always product specific.
Yes.
Weld diameter is relevant, the material, the welding speed, things like that. So we always take a look and calculate the best cycle time, of course. So what is to add? Pretty much nothing. I think we heard a lot, we learned a lot. And again, Konrad, thank you also for answering all the questions. And ladies and gentlemen, thank you for your questions. I hope we made you curious about it. Please get in touch with us, and we are more than happy to show you and explain you even more details and to check which of your components or your product portfolio can be taken onto the machine for a better business case. This is why we are there, and for the future, we want to invite you exactly for this, for a so-called technology partnership. And this is the next point on the agenda. You might remember this slide from the beginning, and this is where I want to invite you again to a partnership. The system, for example, you see here, such a turnkey solution does not come up just straight away. It doesn't come out of our heads only. It's always a cooperation. This is why what I said in the beginning. Excuse me, ladies and gentlemen. So I want to invite you, if you have a new part, a new development, whatever it is, get in touch with us in the early phase, and we try if we can develop the process together with you further in the laser lab to increase maybe speeds or quality, to use the latest laser technology or sensor systems. We want to show or elaborate with you together what kind of automation is really being used for your business case. What is necessary to be more competitive in terms of efficiency, in terms of productivity, in terms of floor space. This is how, for example, the ELC6i also has come up. It is all a result of a strong partnership and cooperations with our customers. Furthermore, I want to point out our software competences as well. We know from the past, from experience, that there are many software tools out there for managing seam tracking or ultrasonic testing, the joining process, whatever. We decided to develop own software tools which are standardized for best access to our systems, our concepts for troubleshooting, for example, and we're also able to customize them to your needs. So what we offer is here like seam tracking, the sensor system itself, the camera with the software tools. We have a system for scanning operations where we use laser scanners with mirrors, for the ultrasonic testing, for the joining, for data collection and other interfacing tools, for example, to bring your HMI on an extra screen. So I want to invite you here to get in touch, to discuss if you're interested. We have the requirement on ourselves to be one face to a customer, also to have the whole access on the whole system. So last but not least, let's take a look at our laser application center. This is basically always the starting point. We do the feasibility tests of your new parts, new components, new materials, whatever it is. We do optimizations, process development. We make prototypes for you and also small series production if necessary. And you see here the machine tools on the pictures here. These are all the technology cells we implement into the real automated systems. Afterwards, we have them available on site here in Heubach. If we change the view here to a bird view, you see there are quite a few machines. We even extended it to the right side. You see it here. There is a so-called laser metal deposition system for the coating of the brake discs. And we have also a grinding machine in order to have the coating and the subsequent process here on site. From a laser perspective, we have a variety of laser sources starting at 200 watts, for example, fiber laser for cleaning. We have the typical laser sources for welding, 6 kilowatts to 9 kilowatts here, disc lasers and fiber lasers. And if it's about coating, we go up to 24 kilowatts of laser power with diode lasers and disc lasers, and in the near future also with fiber lasers. So you see, we are quite well equipped here, and we do not only apply the processes. There's always a loop between measurement, inspection, checking, and applying the application. So we have a very well-equipped materialographic laboratory as well. We are able to grind, to cut, to grind, to polish the probes, to examine them on a microscope. We can do hardness tests. We can do dye penetration testing. And also, if necessary, sometimes we do radiation X-ray tests with external partners. And at the end, we have a measuring room where we, of course, also ensure the geometrical correctness of the parts. So at this point, again, I would like to invite you, if you have new products, new projects, get in touch with us in the early phase and let us be partnerships. A strong partnership is very important from my perspective, especially nowadays where competitiveness is the biggest issue. We want to create innovation together with you. So thanks a lot, ladies and gentlemen, for your attention, for participating and your questions. If you have any other question, please place it right now or any time afterwards. We would be happy to get in touch with you and discuss more details. Thank you very much. Konrad, thank you very much for your support. And we reached then the end. Thank you. Let's take a look at the questions. Oh, there is another one saying, what is the status of the machine and when will it be available? Konrad.
The machine is available now, starting now. As I've mentioned, we are working on projects already, so feel free.
The answer was simple.
Yeah.
All right. So it's no development stage. It's a freshly released machine.
Yes.
If you have a case where it can be interesting, please let us know. We check the cycle times. We check for you the feasibility. We check the number of process steps for you, and would be happy to to create a quote for you. All right, then there's, I think, no other question. Thank you very much, ladies and gentlemen. I wish you a pleasant day. Thank you.